Good morning. My name is Kira Richardson. As the slide says, I'm Senior Lead Program Manager on Internet Explorer at Microsoft. Today I'm going to talk about some tools and techniques that you can use to make your AJAX applications faster. Talk a little bit about script perf tuning, about HTML request caching and optimization. And I'm also here to have a conversation with all of you and find out a little bit more about the types of performance problems that you're having and sort of engage on a longer conversation where we collect the scenarios and programming practices that you're using, create a set of scenario tests and micro benchmarks that we can use to further enhance our products. And at the end, I'll give you my email name, and I'd ask that we start this conversation. I'll also be presenting at TechEd a modified version of this deck that goes into more detail, again, based on the information that you provide me. And we'll long-term be making blog posts on the Internet Explorer blog that highlights the most popular idioms and tuning practices that you can take. The talk is really mostly about making your existing apps today better in IE. Some of the things that I'll show you and that Emery will talk about will work in any browser, but for the most part I'm focusing on Internet Explorer. The problem here is that there's not one magic solution because there's so many different programming practices that people use. And you have to take all of the techniques in their totality to really start recognizing serious performance gains. And as I said earlier, I'll help keep a repository of these tools and techniques on our blog and keep you up to date. And what I'm going to ask is that you help keep me up to date. During the talk, towards the end, my colleague Emery will talk a little bit about a new tool called AJAX View that Microsoft Research is building. I'll also talk a little bit about Fiddler and the developer toolbar. But these are tools that we use to examine existing web pages, examine some of your web pages to figure out what sort of things you're doing on your sites. When we start looking at the kinds of performance problems that people are having, the first set that's probably one of the easiest to deal with and easiest to fix is symbol resolution. And ECMAScript, JavaScript is interpreted language, and so what happens is you have late binding, and every symbol is looked up at runtime, is dynamically resolved in terms of late binding. And what this means is that you have a great deal of flexibility, but the challenge is that there are not a lot of optimizations that happen in this symbol resolution lookup. What happens is when you create a variable, there's a lexical scope that's associated with that variable. That scope is put into a scope chain, and that chain is used by JavaScript to follow essentially a precedence list to figure out where is the scope for the variable and what is the associated value for that variable. That scope chain winds up going from local vars to global vars and to the DOM itself. And so what this means is that when you have expando variables, they're actually the worst possible case. Because you're not declaring them, they wind up being the slowest to actually be defined. And at the end of the scope chain is the DOM. So there's a set of things that I'm going to show you that will help essentially hand tune or optimize and give the JavaScript interpreter some clues about how to speed up some of this name resolution. Let's take a look at this first one. It looks pretty innocuous. You have this local variable and you're getting a value from the DOM. Well, this variable per JavaScript is actually being created globally. So the intent, while your intent may be for this to be a local variable, it's actually created globally with some interesting results. Like if this were an index variable in a loop, what would actually happen is and you didn't initialize it on entry to the loop, this would have the index value from the last time the loop ran. So there are a ton of problems that people wind up running into by having these global variables. And it's really pretty simple to solve. Our recommendation is that you declare and initialize the variables that you're going to use. And JavaScript sort of encourages you to do it either way. But we found that the code is much cleaner if you declare and initialize the variable. And you also wind up having a local var. The scope is not determined for you on your behalf by JavaScript. It's actually done intentionally here. The same thing happens with implicit lookups. So what's happening here is I'm taking a base element and I'm assigning a null value to it, or I'm essentially initializing, clearing it out from the previous run of this build UI function. Now, the next lines, base element.innerHTML equals base element.html plus the title. And so what happens here is I have actually four different assignments. What this actually means is that I'm doing lookups twice for the last three lines. So when I add build title, build body, and build footer, I'm actually looking up base element.innerHTML twice for each of those statements. And I can speed this up pretty easily and have one DOM access. So since the accessing DOM functions and DOM properties are much more expensive than accessing JavaScript, especially local vars, what I can do is take all of the content that all of the strings, making an assignment to a local variable, and then doing one DOM assignment in the function. Now, there is some problem with concatenization here, but that I'll talk about how to improve concatenization. But for the most part, this is definitely much more performant because I'm using local variables and doing a single DOM assignment rather than 6 or 7 in the previous example, as you can see. So if I were making a calculator and I wanted to use this function, this in general is pretty good because I'm doing a local assignment in L side and R side. But what I'm actually doing is accessing the DOM multiple times when I don't need to. So document body.all, I'm actually getting a cache to the collection in the local variable element collection. And then I can actually do the assignment a single time in this function. So for JavaScript, you're not going to get the same sort of performance improvements by caching JavaScript functions. But if you look at this function, for instance, if index were sufficiently large, and I'm calling work multiple times, again, a global variable, by creating a local variable for the function, I'm actually avoiding the scope chain lookup. And again, for sufficiently large number of iterations, this will yield you some perf improvement as well. So for IE symbolic lookup, we have a significant performance improvement by actually caching IE functions. What I'm doing here is actually caching the pointer to the function append child, and since I'm again iterating over it here multiple times, I still have my collection that I'm looking up outside of the scope of this function, but I am actually using a local var here as a function pointer to IE's DOM. So that was all about really symbolic lookup in IE and JavaScript. Let's take a look right now at JavaScript code inefficiencies. String concatenation, through some investigation we found, is one of the areas where there's significant performance gains to be achieved. When you do concatenation in JavaScript with the concatenation operator, what actually happens is you do at least two moves. I have the string, and then I copy, when I do the concatenation, I create a new string of the size of both of the strings that I'm concatenating. I copy the data into that new string, and then I copy it back to the storage for the first string. Now, the number of moves and the temporary string that's created winds up causing the largest part of the perf problems. And so we found that the array operators and array.join are much more efficient, depending again on the size of the string. So for smaller strings, if you're probably talking under 50 to 100 bytes, the concatenation operator it's probably a wash between the two, between array join and the concat operator. But once you get past that, the number of string moves become the limiting factor. And so what happens with array join is that you're not actually creating these temporary strings that are managed by the garbage collector. The string is actually put at the end of the first string. So you have fewer memory moves and much more efficient use of memory. So the recommendation here in terms of strings is use local vars when you can. Cache strings from IE objects. If you're getting values from the DOM, take them and put them in a local var. Instead of using DOM objects in concatenation operations, do all your concatenation using local strings and then do a single DOM assignment. The value add there is that you have a single string that you're marshalling between JavaScript and IE, and that winds up providing significant perf improvements. In examining some of the code that's out there today, I found a great deal of usage of eval. People really seem to like eval. It's a very cool construct. I mean, being able to grab a string from a server and do code injection at runtime is actually admittedly pretty cool. There are some significant downsides to it, and mostly what we see is folks using eval for JSON. So you get some JSON assignment from your server to create some global vars. You do the eval on the string. What happens, though, is we have to construct a new execution context for the script when eval is called. I have to look up the string in the scope chain, and since it's a global var, it's near the end of the precedence of the scope chain. Then I have to parse the string and then execute it. So this, unless you are doing JSON or unless you have some very important need for eval, you should avoid eval at all costs. One of the options that we've seen some people do is use parameterization as a method to get around eval. The issue here is that since you're not downloading the script across the line, there's fewer opportunities for script injection and introduced security risks. Setup and parsing takes less time, but it does require you to plan ahead of time the sort of things that you want to do in your application so that you can avoid the eval hit. And one of the things I've noticed too in doing some web crawler scans is that a lot of the code that people are evaling that isn't JSON aren't wrapped in try except. So there's not a lot of error condition anticipation. And it just seems kind of scary that you're getting the string from across this line that is potentially open without any error conditions. Again, the solution is to anticipate the scope of what your app is going to do and build that code in from the get-go. And use data to drive code. In optimized languages like C, the switch winds up being super efficient. What happens is we usually create a hash table, and the types are usually of the same type. The JavaScript or ECMAScript switch is different. JavaScript and ECMAScript can have just about any type, and when you do the comparison, it actually has to do the conversion if you're using different types in the switch statement. And so the switch processing grows linearly over the number of items that you're comparing. Admittedly, it is an elegant construct. It's easier to see and to read. But you could consider using your own hash table and having a single data type that you're using as the basis for your switch. By doing that, you at least avoid the conversion, and you don't have sort of this linear growth. It's much more efficient. And the reason why this is happening is JavaScript's an interpreted language, and at this point doesn't have an optimization for switch. The other interesting one is width. And I didn't really understand this one. Some of the devs and I were talking about width, and what width does is actually add a new scope. So as soon as you say, for width, it actually adds that scope in the block to the scope chain and increases lookups across your entire app while that scope is active. So you may want to consider not using width. Use manual iterators instead of using width. Again, it's not as elegant. And for a lot of these techniques, you'll see that you're going to be doing a trade-off between elegance and performance. And a lot of them really are about hand tuning or doing your own optimizations for JavaScript, since it is an interpreted language. The other one that I've seen some folks use, again, is accessor functions like get and set. And while this, again, is a very beautiful and elegant system, especially if you're doing validation checking, it does cause another set of lookups to occur. And you should just consider directly modifying the variables yourself. Again, all by itself, this may not be a huge perf penalty, but I've seen people use nested levels of these in their apps in constructors. And so that winds up counting for a lot. So now let's switch topics a little bit. We talked about symbolic lookups between JavaScript and IE. And now we talked about JavaScript perf inefficiencies. Now I want to switch over to IE. Accessing, as I talked about earlier, accessing DOM objects can be pretty expensive in CPU costs. The IE platform is super generic. What happens is we have this COM interface called iActiveScript. There are a whole collection of APIs that allow you to hook up additional languages to IE, other script engines. And this genericness, while super valuable, and we've seen a lot of people very much embrace the pluggability of IE, comes at some cost. And what happens here is that accessing DOM functions, because you're going through this COM interface between the script engine and IE, does cause some perf impact in terms of CPU cycles and marshalling. And what you can do is just be aware of this and try and limit DOM access, or, as I said earlier, use some of the built-in DOM functions like get element by ID is much more efficient than you walking through the entire DOM yourself, because each time you walk, you're actually going to have to pay the marshalling cost between script and the DOM. And that covers accessing and traversing DOM properties. Before I go on to HTTP performance, when folks were coming in, I started talking to people about what the perf problems were that they were running into. And someone asked me about hover, hover CSS style. I primarily focused on this talk around script, but there are also layout performance implications and things that you should think about. As I update the deck and get some of your comments, I'll be posting these along with some of the layout improvements. But hover is interesting. In MIX07, we added the hover style for all elements. And we've seen interesting use. I think there was one W3C site that had hover on just about every element. And the perf penalty is pretty big, because what we essentially do is invalidate the objects, the elements that are around what you're hovering over, and this winds up causing a cascade effect if you have a very shallow document. So if I have a document that's only 1 or 2 levels deep, I have to invalidate all of the elements around it, and if that element has hover on it, it in turn has to invalidate. So we wind up suffering this sort of cascade of invalidation for IE. And one of the easy ways to get around the hover problem is to have deeper elements or deeper document structure, so that and not using hover on every single element will also help. So I can explain it a little bit more, but I just wanted to address someone's question that when they came in about hover. So now let's switch over to HTTP performance, because again, part of AJAX is network performance and getting bits between the server and your client. And there's really a couple of different ways to tune your AJAX and network activity, but you have to really think about how your customer is going to use your site. There are some sites that are meant to be single-use sites. You go every once in a while, and there's only a few activities that you do. Well, if you think about what's actually happening there and use some of the tools that I'm going to talk about later, it's pretty easy to start making those tuning trade-offs. When you go to the site, you know, the browser, the user agent is actually going to download the script, the styles, the images, the HTML across the line. It's going to do a layout and then start executing the script. If you don't visit the site often, there's some really simple techniques you can use to improve network traffic. You can put all the script in one JS file. This one is really easy, doesn't cost a lot, but you actually don't have the overhead of additional requests, and this does improve script download. Same thing with styles. You can put them all in one file. You can have unscaled images. So one of the things that we've seen some sites do, including Flickr, and I, believe it or not, I did it on my site, was instead of having resized images, I actually just put the image on my page and had IE scale the image for me. Well, what's actually happening is across the page, across the net, I'm actually downloading the full-size image and then scaling it once I download it. If I just use the thumbnail across the line, I could save a great deal of network traffic and improve first run experience for my site. You can simplify layout, like I talked earlier about hover and making much simpler layout. That'll start your site. If you look at Live and Google.com, they're both pretty simple sites, and they load really fast. Both sites do some things called what I call speculative downloads, where they start downloading elements for what they think are the next set of pages that you are going to go to. And I'll demonstrate how Outlook Web Access does this as well. And the final one is that you can use HTTP compression. And what a lot of folks don't see is when you put your site on a server, a lot of folks don't like to play with the with IIS or whatever web hosting system you're using, so they don't always get to see that you can set compression for either your site or for individual directories. If you use ASP.NET and AJAX, you can actually do it with directives from ASP.NET and AJAX. So if we take a quick look at what a normal request might look like, I'm going to do this GET, and you know, I'm actually looking for some data, and I'm saying here that I'd accept gzip encoding or deflate encoding. And so the response that I get back is a 200, which means it's okay, gives me an expiration, but the content is gzip encoded. And I'll demo towards the end here what that looks like. But for instance, what some folks don't realize is that you also are paying for these big sites, you're paying for bandwidth. For one major Microsoft site, we use some of these techniques to decrease bandwidth costs by $10,000 per month just by doing this alone. So it was a huge, huge savings. The considerations are a little different when you start looking at perf tuning for subsequent visits. So if I go to your site often, there are a whole different set of trade-offs that I'm going to make, because, you know, I can now cache things that I would otherwise have to download from the server, again, like script and HTML. And one of the main tools that you can use here are conditional HTTP requests. You can have a plain request with no cache, but that's really not going to give you anything. You could use time conditional requests, and you can essentially store resources that you use over and over again in the cache, so that further pages or different pages in your app can wind up hitting the cache instead of going across the web. You can use etag conditional requests, which actually assign this unique identifier to a resource, and then say, hey, just give me this resource if it's changed. There are a collection of HTTP requests, conditional requests, and caching directives that you can use to improve performance. So let's take a look at the first one. This is, I'm downloading, I want to get an image. I'm doing a request for banner.jpg from Baden.com. So now I say, you know, I get a response, and then that response I have an etag. And then my second time I make the request for the image, I can actually say, well, if there's a match against this etag, give it to me from the cache instead of going back to the server. And what the server does is respond back with the 304, which says that the content hasn't been modified, and I essentially get reserved from the cache instead of having those bits travel across the network. This is awesome. I'm still paying the overhead of the request. I'm still paying the overhead of asking the server for the content. So the next sort of improvement on this is not asking the server at all. So if I go back to banner.jpg from Baden, and I've put expiration notices or expiration directives on the resources. In the response now, you can see that this resource expires 12th of June 2009. So we have a little while that this can remain in the cache. Now I could, you know, clear the cache, and you'll see me do that in some of these demos. But the idea here is that, in theory, this will stay in the cache for quite some time. So the next time that I do the request, I actually get no response, because I get the content directly from the cache. No response is sent across the line, and I've not even had to wait for the network traffic for the request to go across the line. So this one is even better, but these aren't always these don't always offer the behavior that you're looking for, and there's several different common cache control headers. There's public, which means that you can cache this anywhere. And I don't know how familiar folks are with networking, but I could have networking devices between me and the server that are potentially caching this content. So public means that it's actually safe to store that content on any of those servers. On any of those network devices. Private is used as a cache directive, a cache control directive that says that the content shouldn't be cached anywhere on any of these network devices, but it can be stored locally on the user agent for caching purposes. No cache and no store are sort of similar, but no store is even more severe than private, because you actually, it's saying to the user agents, be they networking devices or browser, that you can't even store it on your disk or in your local storage. You can set age or even that the content must always be revalidated against the server. And these are all on MSDN. There's the HTTP RFC covers this in detail. I'm just trying to give you an idea of some of the places that you can look to have much more finer-grained control over when resources get downloaded or transferred across the web. So now I'm going to switch over to tools a little bit. Microsoft has a tool called the Developer Toolbar. And the Developer Toolbar is an add-in that we've created for Internet Explorer that allows you to look at the layout on your page, explore the DOM, and really interactively investigate, explore your application. You can make assignments at runtime, and I could do a demo for you afterwards. I thought we may be a little short on time. The other tool I'm going to talk about is Fiddler. And Fiddler is a tool that was written by one of the gentlemen that I work with. And Fiddler is this app that lets you watch the traffic that goes between your application and the server. And then finally, Emery's going to come up here and do a quick demo of AJAX View. So let's take a quick look at Fiddler. Okay. So Fiddler, I took the time to install it ahead of time. But what Fiddler does is installed itself as a proxy. Hey, are folks familiar with Fiddler? I've seen a few people smiling. Okay, so there are a few of you. And what Fiddler does is it installs itself as a proxy. What I'm going to do here is clear the WinINet cache. Remove these sessions. And this is Office Online. So what I'm going to do now is refresh Office Online. And you can see as that's happening, Fiddler is over here showing me all the sessions. And I can do some exploration and look here at what each of these, the results of each of these requests. You can see that this is a request for the script for the page. And on the right side, I can get performance statistics, and I can show a chart. Since I only have one object selected, I'm getting the perf results or actually download results for just that. But I could actually select all of the sessions, and then I get this great pie chart that shows me where I'm spending most of my time. Now, compression actually works really well against text-based content. Usually GIF and other image files are compressed, so the HTTP compression really doesn't give you anything there. But for script and HTML, CSS, and script, I can actually get really dramatic, 50% or better sometimes, compression across the line, and that's going to make your page run quicker. So this page doesn't currently do it, but you can see that I have about 160,000 bytes that are sent between me and the server. So now I'm going to turn on compression, gzip, and what this rule does is it actually compresses for me even when the server doesn't do it, doesn't compress the content coming back. This is a way for me to experiment and see, well, if I did apply compression, what would be the perf results? You know, what kind of performance improvements would I actually get? So now I'm just going to go back here and remove all the sessions, clear the cache, and then I'm going to reload the page. And again, you get to see all the sessions going across. Okay, so it's done. Now let's take a look. And instead of 160,000 bytes sent between me and the server, I have 34,000 bytes. And that's significant. And that could be the difference between, especially on slow connections, a very responsive site, especially for a first run experience. Fiddler has several different tools in here to let you run the site on your local machine as though we're going over a slow connection. I could create rules to hide certain requests, to change my user agent. I could use Fiddler to say that I was Firefox, or use Fiddler to say that I was Opera, so that I could see what kind of responses I get based on my user agent. So it's a super complex tool, but it gives you a lot of flexibility. If you want to do specific actions like perf tuning, this is a great, just the performance statistic tab alone is a great tool. If you're willing to do a little bit more and learn a little bit more about the traffic that's going across, you could actually go and inspect individual sessions. So I can go here and just pick any random session and then look at the header, and I have an XML view of the header, or I can look at this sort of tree view version of the header, a text view. Let's see, I can actually get the raw header. So this is the actual header. This is how I constructed the deck. I made some of these requests, copied the headers out of Fiddler, and then put them into the deck. The other thing that Fiddler, so here's the request builder. So here's where I can go in and make some of my own requests, and this gives me the opportunity to sort of experiment. I don't need to go and write my code and run it in the browser. I can actually start building requests here, do the tuning in Fiddler, setting compression and headers, header control, caching control, to see what is the fastest way. So it's a really cool interactive tool. So now let's take a look at another site. Let me just clean up everything here. Clear up the cache. Let's go to Outlook Express. Now I'm going to just preface what's going on here. So you're going to see me load Outlook Express, Outlook Web Access. And Outlook Web Access is a web-based interface for Outlook that's based on the server. What happens here is I'm going to go to the login screen, and you'll see, I'll switch over to Fiddler quickly, but I want you to pay attention to what happens after the page seems to be loaded. The page is drawn, but you're actually going to continue to see traffic in Fiddler. So the page is drawn, but I'm still getting traffic going across the line from Outlook. And the first time I did this, I was really curious because I just happened to have Fiddler on while I was going to the web page, and I've had a chance to talk to some of the developers. And what you actually will find is you'll see that some of these sessions are actually what we call speculative downloads. And I don't know if you can see it well, but this is an X that appears in one of the toolbars. Because they anticipate people spending a good deal of time at this page typing in their email, their password, what they're actually doing is preloading all of the UI elements into the cache so that when I log into the next page, instead of getting those from the server, they're getting served to me from the cache. And Outlook Web Access actually looked really responsive. And it was one of the most impressive AJAX apps that I've seen. I didn't know that it was doing this. But this is an example of what we wind up calling speculative downloads. I'm downloading, pre-populating the cache for future pages that I intend to use with my app. And this is a technique that you can use. Okay, so that is Fiddler. So now I'm going to invite Emery from Microsoft Research to come up and talk a little bit about AJAX View.
Thanks very much, Kira.
Sure.
Hi, my name is Emre, and I'm going to be talking to you today about a research project we've been working on at Microsoft Research called AJAX View. Sorry. There we go. The goal of our project is to improve web application developers' visibility into how their web applications are behaving inside end users' desktops. So the idea here is that you've written your JavaScript code, you've tried to make it as performant as you can and applied these tricks to make your script faster. But you still don't have the visibility to see, once I give this code out to the user, what are they seeing? What's the customer, the user experience? Is it fast or slow? Are there errors? What are they seeing? And so what we do here is we've built a proxy-based technique to, on the fly, rewrite the JavaScript of your application and add in instrumentation code into the application that will run inside the end user's browser and report back how fast and slow functions are for that user back to the web app developer centrally. And obviously, to make this deployable and easy to use, we have to find a technique a way to get this to work so that it's cross-browser, so that it doesn't require any client-side software changes. And in addition, to be useful for developers and actionable, we want to be fine-grained code level monitoring. So what we've done is, and what I'm going to show you right now, is a prototype of an early technology, well, an early preview of how this is going along, and kind of try to start a conversation on your feedback about different usage scenarios and how you might find this useful as we try and find ways to further develop these ideas. So we've been demoing this at the hands-on lab over the last few days, and perhaps some of you have seen it. But if not, I think it's going to the hands-on lab will still be open for another hour or so, I guess, after this talk is over. And you can go and play with it and see how it works for you. So actually just go ahead and switch over to our demo, and I'll explain what is going on as we go through this together. I'm going to close Fiddler, and the first thing I'm going to do is open up the proxy. And I'm going to run as administrator so it can open all the ports it needs and everything. There we go. So what this proxy is right now is this prototype is a client-side prototype of our proxy. And it's going to interpose on all the traffic coming out of the browser on this machine to any website we go visit. Our technology right now, the way we're doing our rewriting, doesn't require the web application infrastructure to be cooperative in any way. As long as the web application is sending out standard JavaScript, we can rewrite it and insert in the instrumentation that can tell us how it's behaving inside the browser. So I'm going to do a couple things. First thing I'm going to do is clear the cache, make sure that we don't have any uninstrumented versions of a web page sitting inside the browser. The second thing I'm going to do is go ahead and set the proxy settings for this browser to point to the local host. And that's all the client-side changes you need. You don't need any ActiveX controls or plugins to be installed. Now, let me pull this aside so we can see what's going on in the proxy window as well. And really, we're going to visit maps.live.com. They have some JavaScript up on that site. Push enter. There you go. And what's going on now is that this proxy is just intercepting all the requests that are coming through, and on the fly, it's going to be rewriting it and injecting our instrumentation according to our policies. The policy that's enabled right now is a very simple performance profiling policy. It looks for every single function declaration inside the JavaScript code and automatically inserts in timestamps to log the beginning of the function and the end of the function. So we rewrite the function declarations and all the return statements inside it. Those observations of how the functions are calling each other and how long they're taking are being queued up inside the JavaScript sandbox inside the browser and then being reported back via HTTP post from time to time as the queue gets large. And now we can see that maps.live has finished running, and we can go ahead and play with this. Zoom in a little bit and kind of take a look. Let's see, try and find Las Vegas here on the map. And this is working and acting just like the regular maps.live.com. The functionality hasn't changed at all because of our instrumentation. Now, if we want to see what type of information has been being sent back to the proxy from this instrumented version of the code, we just go to a special URL. The proxy intercepts this URL and serves back its own statistics page. We can take a look at these performance statistics. I'll zoom in on a couple of the numbers and increase the font size in a second, but here we have a couple of different columns. One is each of the URLs that we visited, each of the JavaScript pages and HTML pages that have been instrumented while we've been running this application, the number of JavaScript functions on each of these pages, and the performance of the slowest function inside that page. I'm going to zoom in on one called map control. This has a lot of JavaScript, of the core JavaScript functionality of the map in it. And here now we see another page that shows each of the functions in this file. It shows the location of the function inside the file that was returned by the server and the average performance each time, across all the times that this function was called. Let me zoom in a little bit so it's easier to read from the back of the room. And one of the functions I like to look for is the double-click function. That's what I was doing as I was zooming around. So here we see the double-click function took about 70 or 80 milliseconds on average. We called double-click 4 times, each of the times that I double-clicked on the map. And we can take a look at the slowest that this function was and the fastest that this function was. Take a look at the details and drill down into what functions that this JavaScript function was called, so you can see, okay, where is the, oops, sorry, I scrolled around a little bit too much. Where you can look around at where these functions are spending their time and who they're calling, etc. We also have a little bit of support for sorting the tables by performance and things like that. So we can take a look at what functions. Whoa. We can take a look at what functions were taking up the most time during initialization, etc. So really, the nice thing here is that we were able to get a view into how this application was behaving inside the browser without modifying the browser, without modifying the original web app infrastructure, but just by placing this proxy in the middle. And right now, what we're doing, the state of our project, is that we're looking to release the research prototype, the thing that you're seeing running right now, over the next month or 2 on our project website. And we're also trying to figure out what product directions that this could take and trying to brainstorm different types of usage scenarios. One of the ones on our mind, for example, is whether or not this would be useful as a client-side tool as we're using it right here. Another scenario that we're thinking about is whether this would be useful as a server-side proxy or web server plugin so that website owners and developers could see how their customers are experiencing the site under real-world workloads. And we'd love to get your feedback and talk about that. I'm going to switch back over to the slides, and I think there we go. And so we'd love to get your feedback, and I think I'm going to hand it back over to Kira for the end of the talk. Thank you.
Thanks, Emery. So just to wrap things up here, we talked about generally solving perf problems in a few different ways. And the first thing is to identify the type of performance problem that you're having, and we have some tools that are associated with each. So if you think you're having network problems or bandwidth problems, you can use Fiddler. You can watch the behavior of your website, your app in Fiddler. If you've got script or JScript that you're worried about sheer calculation time problems and page load time problems all in one sort of view, you can use AJAX view. If you've got aggressive sort of DOM access, you can also use AJAX view. In general, the advice that you've seen, I think, throughout the deck is to reduce, simplify, cache when possible, and refactor. Again, there are a lot of trade-offs here, and this is meant to give you some insight into how Internet Explorer, the DOM work, how JScript work, so that you can optimize your code based on the situations that you have. And again, reduce the number of bytes, simplify your code, and cache DOM properties. Here's some resources for where you can get Fiddler. These will be available on the MIX site for you, I think tomorrow or the day after. And I really encourage you, Emery and I are going to stick around, and I'd like to have a few questions at the end here. But then we'll stick around, and I'd like to find out from you what sort of problems, performance problems you're having, what sort of tools you need, so that we can bring that back into the product groups. And I'd encourage you to take down my email name. I hope you can see it up there, and send me email after the conference. And finally, thank you so much for coming out early. I know it was 8:30, the last day of the show, and I really appreciate you all coming out. Thank you. Is anyone awake to ask questions? Are they waking up to? Yeah.
Sure.
Can you use the mic? I ask that you use the mics because they're recording us for posterity. And if you use the mic, then it's recorded and everyone can hear you.
Question one is, does Fiddler work with any browser that's open? Does it capture any web traffic or only IE?
Fiddler will work with any web browser or web application that uses WinINet on Windows.
So with AJAX applications where the user is potentially spending a longer period of time
Sure.
on a single page, in an earlier session, there's been concern raised about memory leaks that can arise as content is entering and leaving the page. Is there any general tips for cleaning up when you're done with a certain piece of content or unregistering event handlers and that sort of thing?
So the question was, there are increasing concerns about the potential memory leaks or actual memory leaks when one page is active for a long time and data is coming in and out of scope. And there are a few things. I think in general, IE and the JavaScript team are looking at what we can do to help identify variable lifetime so that we can make the garbage collector smarter. And if you look at IE7, we actually did do a number of garbage collector improvements to help some of the AJAX scenarios, and I think we got to some of the big problems. The challenge here is that the garbage collector doesn't always have insight into the lifetime of your data. And so right now, there's not a lot that you can do other than try and do single large allocations instead of lots of little allocations. It's kind of difficult because there are a number of things that happen behind your back. So like the concatenization example, when you do those kind of operations where you get a temporary string in the garbage collector, that could increase memory pressure and in turn cause some memory leaks. Let's get together afterwards. I'd love to find out more about your page, and maybe we can instrument your page with some of our tools to figure out, exactly what kind of problems you're running into. Next question.
Hello. One of the things, IE7 that we would like to see is the ability to selectively enable and disable debugging on a site level basis. It's really frustrating, when you have it turned on and then I'm visiting CNN.com. I don't want to debug or step through CNN's JavaScript code. So I know you probably won't have a feature like that in IE7, but it would be nice if you all could create a plugin, simple plugin that would just enable and disable. Firefox, you can download a plugin that would do exactly that. So.
I'm going to repeat the question, and I'm smiling because that's one of the specs that I'm responsible for working on. The question is, let me give you an example. So I'm working on my page, and I've got debugging enabled, and I have another page open in another instance of the browser, and that has MSDN or some other reference in it. Well, right now the behavior is that debugging is turned on for all sessions of IE, not for just the one that you're trying to debug. And if any of those pages in the reference material, for instance, has a bug, you get this hideous little dialogue that says, there's an error on line 20, would you like to debug? Yeah, we know about the problem. I'm actually, I should be back at the office on Thursday writing the spec for that, and we're trying to get it in as quickly as possible. The Orcus guys expressed interest in this as well because they want to be able to provide an update so that you can have what we call single instance debugging.
Can we expect something next week?
You can expect something. Yeah.
Firstly, I'm really glad to see the AJAX View tool being developed. I think there's definitely a lot of potential. Another plug I'd like to make is for Nikhil Kothari's web development tool. Nikhil Kothari.
I'm sorry, I couldn't hear the last.
Nikhil Kothari, he's an ASP.NET architect. He makes a web development helper tool.
Okay.
And that lets you examine a lot of the AJAX traffic going back and forth. I think that should also be listed. Coming to a question, is there anything that will help me evaluate IE rendering time?
So the question is there anything that can help you with IE at rendering time?
Anything that will evaluate, from a performance perspective, like how long did IE take to load the page, render the page, whether it's rendering, evaluating all the JavaScript, client-side JavaScript, or actually rescaling images, all the rendering stuff that it does.
Sure. So it sounds like what you're actually asking for is some instrumentation on IE's behalf to understand what the impact is on your behavior in your app on rendering. And right now, I think we don't have anything. We don't have anything currently that does that. I think that what we've seen some folks do is actually do experimentation between things like tables and floats. Like there's some people who just don't like tables because of the inelegance of creating a page like that, and they want to use floats. And there's different trade-offs depending on the size of your content. And so my answer right now, unfortunately, is just you're going to have to just do some experimentation. But what I'd like you to do is send me some email with specifically the kinds of rendering problems that you're worried about, or where you think your app is spending a lot of time, because I'd like to figure out if there is some sort of tool we can provide, or at least some documentation that it sounds like maybe even documentation would help you out. Okay. So we're just going to come down here, and we don't need to use these mics anymore. We can have sort of a more interactive conversation. Thanks again for coming.